All right, guys, I'm going to talk about plate tectonics. So get ready, get out a piece of paper. You're going to be page 17 in your notebook, so get out a piece of notebook paper, and you're going to need to start copying. Okay, guys, here's your learning objectives. So basically, you're going to have to know the theory of the plate tectonics, and you're going to be able to explain what causes plates to move. You're going to be able to tell me the different types of plate boundaries based on the type of crust and the direction of movement. And then you're going to be able to explain how land masses, those are things like ocean trenches, mountains, volcanoes, and islands, how are those formed in association with the different plate boundaries?
I hope you have never been in a car accident, but I know we all have seen one in our lives. If you have watched many movies, you almost certainly have. Have you noticed how even when the car is no longer at the accident site, you can tell what happened to it, like where it was impacted, how fast it was going, or the other car was going, and what part was hit first? Even without impacts, perhaps you can piece together what happened when a scratch shows up on the side of the car. As tectonic plates of the Earth, or giant pieces of the Earth's crust, move and crash into each other, similar telltale signs show up to give us some ideas about how they move with relation to each other. The theory of plate tectonics states that the crust of the Earth is broken up into large pieces, or plates, that move around by floating on top of the liquid layer of the Earth known as the mantle. This theory was the result of decades of work and observations made of the Earth's surface. It is still the first model to neatly explain all the pieces of data scientists couldn't explain when they thought the surface of the Earth was stationary. The map may seem confusing at first, but the main thing is that the colored lines show the lines where the crust is broken up into many different plates. Most are named after the continents that are contained on them.
Okay, your notes begin now. Remember, you always write down whatever is underlined. That's how notes work in my class. That should make it easy for you. So we're going to talk about that theory of plate tectonics. That's something that you're going to need to know by the end of class. What is the theory of plate tectonics? So basically the Earth's lithosphere, and that's the outermost shell of the Earth. It contains the crust and it contains the upper layer of the mantle. It's basically broken up into all these little pieces, kind of like ice cubes on a punch bowl. So you have all of these different plates that sort of fit together like a jigsaw puzzle. They're all right up next to each other. And they're usually named after the continents that are on them. So for example, here's the African plate, the South American plate, North American plate. And then you can see where all of these are moving in certain directions, okay? They're kind of sliding around on top of that partially melted asthenosphere, which is part of the atmosphere, or the mantle, sorry.
Some plates are entirely oceanic crust, or crust under the ocean, while others are a combination of oceanic and continental crust, which is crust of the continents. The boundary where two separate plates meet is where all the action occurs and is called a fault. A fault is a crack in the Earth's crust resulting from the movement of the two plates.
Okay, so faults. A fault is a place where two plates come together, and it's just like when I was looking back at this last picture here, where we had all of these plates. Faults are the spaces in between. They're also known as plate boundaries. So we've got these plate boundaries. So we've got our plates that are coming up next to each other, and they're going to be moving. So there's going to be pressure either pushing together or pulling apart. Either way, we're going to have fault lines between each of those boundaries. Fault blocks are the blocks of crust on either side of the fault. Okay, a couple of vocabulary words. We have uplift and subsidence. They mean the opposite of each other. So uplift is where the ground will move up to a higher elevation because, for example, two plates run into each other and one will start to go down and one will start to go up. Subsidence is the sinking of Earth's crust to lower elevations. So they're opposite.
This process is driven by convection currents within the mantle. Convection currents are formed by hot magma near the core rising towards the surface, while cooler magma near the crust sinks, setting up a current that causes the plates to move. These currents are the primary driving force behind plate movement.
I'm not going to put my face on this one because it takes up space in the upper corner that would block some of the writing. So keep writing. We're going to talk about the forces that drive plate tectonics. In other words, why do the plates move? And they move for three reasons. They move because of ridge push, because of slab pull, and because of convection. Let me talk about convection first. I know I have it written last. Convection is basically when you have a hot fluid like the mantle flowing upward as it rises because it's hot. It's hotter down towards the core. So heat rises, as we know, and it's going to start flowing upward as it rises. But as it rises, it's going to begin to cool as it gets closer to the Earth's surface. So it's going to start sinking back down. So we end up with these circular movements in the fluid structure of the mantle. And what happens is we have it rising at certain points, and it will begin moving the mantle along underneath the plates. And it's essentially going to cause the plates to move apart at this space called the mid-ocean ridge. And that mantle is going to kind of bubble up in between them and fill in the gap. Okay, so that's convection. Next, we have ridge push. Now, I just talked about that mid-ocean ridge. See how the mid-ocean ridge is actually higher than the rest of the crust here? It's a little bit higher, so you can imagine how gravity is going to push that whole plate. Here's the plate, okay? It's going to push that plate down by gravity. That's what ridge push means. Slab pull, on the other hand, when we have a plate sinking under another plate because they have run into each other, one will go underneath and it will begin to sink down toward the core. And as it sinks down toward the core, imagine if you put like a chain on the surface of the edge of a table and you put that chain over the edge and let it hang. What's going to happen? Well, it's going to start going down, down, down more and more, and it's eventually going to pull that chain all the way off the table until it's on the floor. And that's what happens to this plate. It's being pulled by gravity on this end. So that's what we call slab pull. And all of these work together to move the plates around.
Getting back to the example of cars, when two cars are next to each other, there are three possible ways for the cars to move with relation to each other. Plates act in a similar manner.
Okay, so I talked a minute ago about faults, and that has to do with plate boundaries. And plate boundaries are where the plates meet, come together. There are three types based on the direction that they're moving. We have transform boundaries, which basically means we have two plates that are up next to each other like this, and one is moving this way and one's moving that way. So they're sort of sliding past each other. And of course they're not really smooth, so they're like constantly jagged. So that's going to cause a lot of disruption and movement of those plates, and sometimes those movements can be sudden. So that sudden movement is what produces that earthquake. So they're very common at transform boundaries. Earthquakes are actually common, happen at all boundary types, but very commonly the strongest ones are going to be associated with a transform boundary. Then we have the divergent boundary. So here's my little plates again. Divergent boundaries happen when the plates are pulling apart from each other. They're diverging, becoming two. So what happens is they're spreading apart, and in this space in between, magma is going to be bubbling up and filling in the gaps. And it will cool, and then it will eventually form new crust. Okay? So that's what we call a divergent boundary. Then we have a convergent boundary, the last type. And a convergent boundary is where two plates come together and they push toward one another. And we'll talk about kind of how that happens, but basically what happens is one plate often goes underneath and the other goes on top, unless we're talking about two continental plates. But I'll talk about that in just a moment.
A third way that plates can interact is by sliding past each other. This would be like cars sideswiping each other. One car is moving one way and scrapes by one going the other way. Tectonic plates do this as well, grinding past each other as they move in opposite directions. This third type of plate boundary is called a transform boundary. The most famous example of a transform boundary is the San Andreas Fault in California. The San Andreas Fault is the edges of the Pacific Plate and the North American Plate. The fault line runs through the Gulf of California and through the western part of California before running back under the ocean. The Pacific Plate is moving northwest with respect to the rest of North America at the rate of several centimeters per year. This means that thousands of years in the future, San Francisco and Los Angeles will be on a piece of land that will break off from the rest of North America and move out into the Pacific Ocean as an island. Remember that this piece of North America is on a different plate, which the whole thing is moving. This part of California is not drifting around like a boat in the ocean. It's moving as a part of the whole plate, which is moving northwest. At this type of boundary, the only effects are earthquakes. The sliding process is not smooth and moves in fits and starts. The pressure for the plate to move builds over time, and the rocks compress and strain. At some point, the stored energy is released as the plates move, which can be several feet at one time. When it does, an earthquake occurs. There is no mountains or volcanoes forming from this boundary, no matter how many Hollywood movies are made that portray volcanoes erupting in Los Angeles.
Okay, let's talk again really quick about transform boundaries. Transform boundaries are these ones that are sliding past each other, next to each other, and then you end up with these earthquakes that happen. And that's because they are jagged, and so they don't actually slide smoothly. They slide kind of in jerks, and so we end up with these transform boundaries causing a lot more earthquakes than the other types. The San Andreas Fault in California, which is why California has so many earthquakes, is all the way along throughout California, and so you end up having all of these earthquakes in California.
Plates also can pull apart from each other. This is known as a divergent boundary. A divergent boundary is a fault where the two plates are moving away from each other. Now, as plates pull apart, several things may occur. First of all, volcanic activity is common in these areas, since mantle easily moves to the surface through the thin, fractured rock as it separates. Volcanoes are a sign of a divergent boundary. This happens all along the mid-ocean ridge, where magma is constantly streaming to the surface, creating new ocean floor as the plates separate. If a continent happens to be a place where a divergent boundary occurs, then the continent will begin to be torn apart as the sides of the plates separate, creating a rift valley. The African Rift Valley in East Africa is an example of this occurrence. Eventually, the ocean will separate East Africa from the rest, making a large island.
The next type of boundary I talked about are divergent boundaries. Divergent boundaries are caused because the plates are moving apart. Now remember what I was talking about, that magma is going to come and fill in, sort of bubble up in between, and fill it in, and we end up with what's called a ridge, a mid-ocean ridge, that's sort of higher than the rest of the ocean floor. And that's because that magma is bubbling up underneath and sort of building this ridge in between the two plates that are moving apart. We call this process seafloor spreading because the floor of the sea is spreading apart. Pretty simple. So, as seafloor spreading happens, we get new crust forming. So, seafloor spreading is associated with new oceanic crust. Okay.
crust colliding. Remember that at divergent boundaries, new crust is being made, but the Earth is not getting larger. Why not? Well, at the opposite ends, crust is being pushed into the Earth's interior by colliding plates, and being remelted at the same rate, new crust is formed. When cars impact each other or another solid object, the energy is transferred to the cars themselves, showing up as dents, ripples, or cracks. Plates also show telltale signs of colliding too. This happens at a convergent boundary. A convergent boundary is a boundary where two separate plates are pushing into each other. There are two kinds of surface features that are associated with a convergent boundary. The first is a deep ocean trench that forms a line of the two colliding plates. One plate, made of oceanic crust, can slide down underneath another plate, forming this narrow, deep trench. This happens because oceanic crust is more dense than continental crust, making it more likely to be pushed back into the mantle. These trenches are the deepest places on the face of the Earth, extending over 30,000 feet below the ocean's surface. You could take Mount Everest and sink it in the Mariana Trench, the deepest point in the ocean, and still have a mile to the surface of the ocean. That's deep. As one plate is forced under the other one, it begins to melt and a line of volcanoes forms in a parallel line to the trench.
Now I'm going to talk about the last type of boundary, but there are three types of this last type of boundary, and they're called convergent boundaries. And they occur when plates crash into each other. So what happens when plates crash into each other is oftentimes one of them will go beneath the other and one will go on top, but sometimes they both go up. Okay? So we've got three different types of convergent boundaries. Think con meaning coming together. So three types. The first one is the continental, where we have two plates of the continental crust. And do you guys remember which crust is thicker? Is it oceanic or is it continental? Continental is thicker. So we have the denser plate going beneath the less dense plate. So the oceanic crust, which is much denser and thinner, is always going to go underneath another one, but two continental plates are going to have about the same density. So let's talk about each of these three types.
If both plates are continental crust, the plates will crumple up as they collide, forming a high mountain range, much like the Himalayas. Continental crust is less dense than oceanic crust and does not get forced into the mantle. The crumpling of the continental crust is similar to two cars colliding, as in the example from earlier.
Okay, so I was just talking about continental convergent boundaries. So convergent again means that they come together. And if you've got two continental crusts, they're going to come together and they're both not very dense. So what's going to happen is they're going to push up and form mountains. So that's where we get what's called the folded mountain chains, these folded mountain ranges, okay, where both plates are pushed upward. Okay, so we get our highest mountain ranges in the world because of this. The Himalayas, where Mount Everest is, the Rocky Mountains are very large mountains, the Alps in Europe, the Ural Mountains in Russia. The Appalachians were also just as big as the Himalayas, except now they have eroded down because they're a much older mountain chain.
If the other plate is oceanic crust, the line of volcanoes will become islands like the Philippines.
Okay, the next kind of convergent boundary is going to be the continental oceanic boundary. And this is going to happen when we have subduction of the oceanic plate underneath the continental crust. And this is because it's more dense. So that's why it's able to go beneath it. And what happens is you will have all of this magma starting to bubble up underneath the continental plate that's on top of the subduction zone. And the subduction zone is this area where you have the plate that's being subducted. So we have what are called volcanoes, and these will form all along this edge in a chain of volcanoes. We see this like in the Andes Mountains. We see this in Mount Fuji in Japan, Mount Rainier, which is in Washington State. And it forms what we call the Ring of Fire. The Ring of Fire is the rim around the Pacific Plate, and it's a ring of volcanoes that surrounds that. So the other thing that forms, of course, is a trench. So anytime you have this one going down, that's going to make a deep place in the ocean there. So you can kind of see. So this trench forms, volcanoes form on land, and we get this ring of fire because of the subduction zone.
And if it is continental crust, then it will become a line of volcanic mountains, like the Cascade Range in the western U.S. or the Andes Mountains in South America.
All right, last kind of convergent boundary is the oceanic, where the crusts come together and they're both thin and dense. One of them will be denser and one of them will go beneath the other. And you'll get the same thing that you got with the continental crust, except now instead of having volcanic mountains, which are above the ocean, now we're going to get volcanic islands, which are actually just underwater volcanoes. Okay, so what you have is we have this subduction zone here as it goes under, and this is the oceanic crust, and this is oceanic crust. Both of them are under the ocean, as you can see. And what you can see here is a volcano is going to form, except it's not a mountain, it is an island. So you see these rings of islands forming in the ocean. So we also, of course, get the trenches, just like we did with the other one, because we have that plate that's diving down under the other one because of subduction.
No matter which type of crust is colliding, you will see volcanic activity if one is oceanic crust, because the more dense oceanic crust is pushed down into the mantle. As it is forced down, it begins to remelt, and the magma forces its way to the surface to form the volcanoes. All types will form strong earthquakes, forming from the plates grinding together as they slide under. To recap, there are three types of plate boundaries that are formed by the interactions of different plates. The third type is transform boundaries, or a boundary where plates slide past each other, forming strong earthquakes. All of this crashing, banging, and erupting are one reason why the surface of the Earth has such a variety of landforms and features. Divergent boundaries are boundaries where plates pull away from each other, forming mild earthquakes and volcanoes as magma comes to the surface. Convergent boundaries are boundaries where two plates are pushing into each other and are formed when two plates collide, either crumpling up forming mountains or pushing one of the plates under the other and back into the mantle to melt. Convergent boundaries form strong earthquakes as well as volcanic mountains or islands when the sinking oceanic plate melts.
All right, guys, that's it for plate tectonics. You have a test on Thursday. You are to be working on your study guide and getting everything together and ready for that test on Thursday, so make sure that you are prepared. Bye.